So we had done the moment of force and we saw torque. Actually, we did the torque, which we call the moment of inertia. No, it is moment of force. Okay, it is moment of force. Okay, and we saw that it is a vector and it is given by r cross f. It's given by r cross f. Fine. I'd like you to understand this at the outset. You have been taught that your r is a position vector, is it not? R is a position vector, and how does a position vector act? It acts from the origin. Correct. It acts from the origin. So let us say if I have set this as my origin, and since we started with the example of the door, I'll draw that door once again. Maybe not here. Maybe something like this. Okay. So let us say this is my door, and okay, so something like that. Looks like a door, yes. Fine. Okay. Now I applied a force, say in this direction, perpendicular to the door, say at the end of the door. Okay, here, right at the end. So what is my r vector? What according to you is the r vector? Yes? The length of the door. Okay? It is wrong. R
shortest distance from the axis to the point of intersection.
Wrong. Again. That too is wrong.
Shortest distance from the axis of rotation to the line of action of the extended line of action of the force.
No.
Shortest from the origin.
Yes. Position vector still remains that. I want you to understand that. The position vector still remains what you were taught in the beginning of the vectors. It still remains that, and it still will remain what? It will remain the vector that starts from the origin and points to this.
But aren't we at the liberty of shifting our origin when we have
You have, but once you have fixed it, you have fixed it.
That's our.
But if you are at the liberty, then what happens if I shift my force here? You'll shift the origin along with that? I am not bound to apply the force at the place where the door knob is.
Why don't we just shift the force instead of shift?
So if I shift the force and you say that initially you fix the origin here so that your R is this is what you mean to say. What happens if I start applying the force here? Then this origin remains here. So what will be your R? You understand the question first. What I am saying, what is that R becomes very important, and that r, if it is a position vector, it has to be drawn from the origin and not from some line, and you do not have the liberty to shift it. No? No. We don't get it? You don't get it? Fine. So that it still remains. Now it's all in 3D and it looks as if they are in the same line. They are not. They are not. So for that, let me draw another figure. So say this is your fixed axis, and say this is your rigid body, and at any point of this rigid body, say at this point, and this point, maybe even within the body. I can do all sorts of things. I can bore a small pinhole and maybe affix something with a Fevikwik and then start pulling the object. So it's quite possible for me to do all that, right? So if my origin is here, and it is not essential that you always take the origin outside the body, but once you have taken the origin, you are bound to remain there. You are fixed. You simply cannot shift it. Okay? So from here, my R is actually this. This is my R, if this is my point. Okay. Now this R is composed of what? It is composed of two vectors. This is my R vector, and my I'll show you. So this vector is this is O, this is C, and this point is P. This is the perpendicular. Okay. Not clear in the 3D? No? So it is maybe shifted like this. Had it been here, had it been right in the plane of this, you would have seen this to be something like this. Get it? So it is more towards, it is off the plane, towards you, towards the portion that is towards you, that is projecting out of the board. That's why I have drawn like that. Makes some sense? It makes some sense. Fine. Now this R, which is OP, and say my force is say something like that. Okay. Not necessarily at 90 degree. Not necessarily at 90 degree. Not necessarily in the horizontal plane. It can be anywhere. Now try to think. I have defined my torque as R cross F. And my R is nothing but OC plus CP. This is actually OP cross F. So this is OC plus CP cross F, and the vector product distributes over addition. Okay, so it becomes OC cross F plus CP cross F. Okay.
We haven't made the vector sign for CP.
For CP, this is CP. So now let us try to find out what is OC cross F. What is OC cross F? OC is like that, right? It points in the direction of the axis.
Is there an angle that R makes with the origin?
Hmm?
Is there any angle that R makes with the origin?
Obviously, R has to make some angle with the origin. Obviously, it will make some, and it cannot make an angle with the origin. It has to. It's a point. So it has to make an angle with whatever axis you want. So so with this fixed axis, obviously, it is making an angle, right? So now try to understand. This is your OC, and say this is your F, or this is your F. Okay. Now, what is the direction of this? What is the direction of this? Suppose this is your OC and this is your F. Okay. So I get it here. OC cross F. No? The first vector goes to the second vector. That fundamental is clear for a cross product. No. Okay. For those of you whose cross product fundamentals are not okay, or vector fundamentals are not okay, you go and watch the video of vectors for class 12th. It's there. Okay. So someday you take some time, come and watch that full. Okay, through and through. So you'll understand. So it is OC cross F, and OC cross F is in this direction. Correct. Okay. When the torque is in this direction, it means the rotation is like that. This force tries to rotate like this. Is it not? Do we understand that? Now, if the axis is fixed, if you try to rotate this body like this, then the axis of rotation has to shift. Is it not? Otherwise, it's not possible. It's not possible to give it a torque like this, to get a torque in this direction. OC cross F. It comes here, OC goes to F. That's what we do with the vector product. The first vector we take to the second, see the direction, looking from your side it is clockwise, no? Clockwise, so you turn a right-handed screw in that direction and see the linear motion of it. Okay, and see the linear motion of it, where does it go? So maybe you have a bottle? So this is a right-handed screw. In fact, 99.9% of the threaded screws or bolts that you'll come across, they are right-handed. Okay, very rarely they are left-handed. So this is actually a right-handed screw. So what happens if it was open, or you have an empty bottle or something? No, none.
You just use the marker. Marker like that.
But marker is actually a pull and push kind of marker.
No, like you can open the ink.
That is a left-handed screw.
This is all. Wow. Screw it. I can open and close it.
So what criteria have you decided the length of OC?
What?
On what criteria have you decided the length of OC?
Length of OC,
Yeah.
such that my CP is perpendicular to this.
Why are we taking it?
That you'll come to know. That you'll come to know. Okay, so this is OC. Okay, this is OC, and OC cross F was pointing in this direction. For that, the whole body has to turn like this, you know. So this whole thing, it has to turn like this if you want a torque in that direction. Because if it starts turning in that direction, the angular velocity also goes in that direction, in this direction, right? Now we are talking about the axis which is fixed. Fixed. So this is an absolutely rigid kind of thing. If it was a door, you are trying to turn the door like that, the axis of the door like that, which is not feasible with the kind of forces that we apply on doors. Okay. With the kind of forces that we apply on doors, that is not possible. So what happens? So what happens? This torque is not producing any movement and hence is not a torque at all.
What will act?
It will act. It will act. But it will not lead to any rotation. As far as the impact of rotation is concerned, it will not rotate it. Yes, if your axis is a bit weak, obviously it can break it out. Obviously it can do that. But I have still not gone to that. Okay? I have still not gone into that, and due to this, what happens? The torque that actually causes the rotation is only this, which actually makes it rotate. Okay? And this is what? So I went OC, and then there was a 90 degree, and then there was a 90 degree, and then there was a force. Correct? Correct? So now I come here. I have understood that OC cross F is gone. Why gone? It is not that this torque is not present, let me tell you. But this is a torque which will not cause any rotation in a fixed axis system.
Why is that?
Because the axis is fixed.
So OC cross F won't cause any
Rotation. Because I am saying that my axis is a rigid, fixed axis. And when I say it is a fixed axis, I mean to say whatever amount of force or torque that you apply on it, it will not budge. It will not move from where it is. This is what it means actually.
If the axis is strong enough.
That's what we are considering. It's not that if the axis is strong enough. It is strong enough. It is strong enough to resist whatever force you apply on it, even infinite. Because we are considering a fixed axis system. Okay, we are dealing with a fixed axis system, and hence this force doesn't cause any rotation. Any rotation. Okay. Now coming to your question, you said why do you take it that long that CP becomes a perpendicular? Why? Because CP in that case becomes the shortest distance, and it is easy to understand in those terms. Otherwise, what will you say? Suppose you say no, it is not the shortest distance. It still makes an angle of 20 degree with the shortest distance. It will complicate the matters like anything. And the result will remain the same. Let us be very, very clear about it. Because the result it is not actually, see, you have applied a force, The thing has to rotate, it has to rotate. It does not know what you are doing in the background. You are taking the resultant of the R as something or this thing or that thing. So I have to find out the easiest way out, and finding out the shortest distance which is perpendicular to this is the easiest way out. Okay, and there will be no trouble. You take it to be making an angle of 20 degree with the shortest. That will also work. Okay, but it will not give you any advantage. Rather, you will be at a computational disadvantage with it. And also, while understanding, you will not understand what is my R and from where I am acting and where the torque is going to be. But while it is a straight line that you can draw and visually see, it will give you a computational as well as an imagination advantage. Okay. Now what happens? So this was OC, this was CP, and say this is my F. Understand? So OC, CP, this is your R, this is your F. OC cross F is gone, does not produce any rotation. So I am left with CP cross F. Okay. Now CP cross F is like what? It is like that. It is what is the vector product? The resultant of the vector product, the vector product is a vector that is perpendicular to both the plane containing both the vectors. So it is acting in this direction. Now this two can be projected in two mutually perpendicular directions, this and that. It's not. This vector can be resolved, resolving the vectors you have studied. It can be resolved as a vector that points up and as a vector that is at 90 degree. Now this component of the vector again tries to turn it like that. So that is also gone. So the vector which actually, so after you have taken everything, the vector that points in the direction of the axis is the only vector that will do something about it. Otherwise, all other vectors have no business being there. So ultimately what happens? Now again come back. OC, CP, this is a vector like that. Now this component of the vector. So I am not resolving the torque. You could resolve the torque, I am resolving the vector. This vector again has two components. What? A horizontal one and the vertical one. The vertical tries to bend you like that, and that was the component that was pointing in this direction. It will come exactly the same. So you resolve the force and then find the torque, or you find the torque and then resolve the torque. Nothing is going to change, and that's the beauty and simplicity of it. So this tries to turn it like this, not possible. It is this which actually turns it. So ultimately what happens, in the end of it all, what happens, whatever is your force, you take the force that is perpendicular to that lies in the plane of rotation. That means that is perpendicular to the axis, lies in the plane of rotation, and you take the R which lies in the plane of rotation and just cross product them. Do we get it? No?
Without resolving.
No, after resolving. Otherwise, how will you get the horizontal component? So if someone says it is a rigid body, say kind of this, and I am applying a force like that, obviously it is rotating like this. So you resolve it in this plane. So whatever is this force, if this angle with the horizontal, the angle is theta, then this is F cos theta, maybe phi. So F cos phi, and whatever is this, okay, crossed with R, crossed with F cos phi. This angle I am saying with this horizontal, this is the horizontal, this is a line, this is making an angle of phi. Okay, so F cos phi lies in this plane, okay, and this R, though R is this, still for the torque I am using the shortest distance of R.
Because that won't
Shift it here. Why? Because for finding the angle when you are taking the vector product, you make them co-initial vector. You make them a co-initial vector. So shift it like that, take this angle. If this is theta, then it becomes this component was F cos theta multiplied by R in F cos phi multiplied by this not R, this is Cp into sin theta.
F cos phi cross R.
Not R, Cp. R is this. R is this.
Yeah.
So Cp cross F cos phi. And no wonder, see, there is a, I do not know.
And
I do
again,
not know.
CP becomes the shortest distance from the axis to the point where the force is applied. So why not we just
You
Okay.
could just extend the
Mhm.
line of action.
Why
of
not
the
we just-
force, right?
I got it.
Mhm.
You could just extend the line of action of the force down to where, taking from the origin, you get the shortest perpendicular to the line of action of the force, and then just cross those. It's the same thing.
That's what I was coming at. It will finally become that.
Yeah.
But the that part which is horizontal with that, the other part is defunct.
Right. Exactly.
The other part of the force is defunct, the perpendicular one. So what happens? As children, you must have, I don't know, you must have hung on to some gates, some big gates, and you just keep on giving it a tug with your feet, and so you were exactly doing that. You were exactly doing that. The force that you were applying by giving a tug by your feet, that was the force which was propelling you. So for example, you go and just hang there, it will not move. You just stand over the gate. It didn't move. Why? Because you were applying a force that had no horizontal component. You know? So you were you were applying a force that had no horizontal component. And what do you mean by horizontal component? It is you take a point, rotate it, so it'll trace out a ring, is it not? The plane of the ring is the horizontal plane I am talking about. So it has to lie in that. Only the forces which lie in the plane of that will be able to rotate it. And then too, the angle also matters with the R. It's not that I have this, okay fine, a huge force I have applied, making an angle 0, nothing doing, it won't move. So I have complicated it, or I do not know, uncomplicated it. If you study, you will understand what I am trying to tell, okay? And they have discussed it at length, but have this picture in your mind. Why the vertical component of the force is simply not going to produce any torque? Because it tends to move the axis itself. It tends to move the axis itself like that, and the axis, in the beginning we have said, is fixed. It is rigid. Okay, so we get the point. So this does not cause any rotation, so it is only this, and even in this, the force that is perpendicular to the axis of rotation, the force which is the parallel one is not able to produce any torque at all. So it is only this causes rotation. This force causes rotation. This torque causes rotation. Okay? So rotating torque is equal to Cp cross F. Now this F, as I said, see, just see again, Cp, this is Cp, and this force was acting here like that, and it had a perpendicular and it had a parallel to what? The axis, and perpendicular component. So again I am writing, this is Cp cross F parallel plus F perpendicular. You understand what I did? The F part here I resolved into two. The parallel to the x-axis and parallel to the axis of rotation, and the perpendicular. This is perpendicular, no? It does not look perpendicular, but this is perpendicular to this axis, the black pen. This is not. One which is in this plane, in the plane of the CP, in this, that is perpendicular to this. Why? Because CP is perpendicular to this. So, this is equal to CP cross F parallel plus CP cross F perpendicular. Now this again does not cause rotation. Doesn't cause rotation. This causes rotation. So where has my fundamental boiled down to? The component of the force which is perpendicular to the axis and the R which is the shortest. They have to be crossed to understand the actual torque that is actually rotating the body. Everything else is defunct. It is not that it is not trying to rotate, but with the constraint that the axis is a rigid one, it is not able to rotate. Okay, it is not able to rotate. So for a fixed axis system, the component of the force parallel to the axis of rotation is not able to rotate a fixed axis system. Okay? It is the component which is perpendicular to the, I'll call axis of rotation as AOR, and you don't write it in your exam. Okay? It is the component which is perpendicular to the axis of rotation, which causes the rotation in a fixed axis system. Hope that is clear. Why? Why it is not able to rotate? So whatever force you give me a force in some awkward direction, I'll first bring it in the plane. In the plane of rotation, or you can say perpendicular to the axis of rotation. And at that point, from that point, I'll take the shortest distance to the axis and I'll just cross them. That's all. Fine.
But
Okay.
CP and F, won't they make an angle of 90 degree always?
CP, no? Why? Why? They are absolutely independent. CP does not compel me to say that you act perpendicular to me. Why? Why am I compelled?
CP is only perpendicular to the axis of rotation. That's your only condition.
Yeah, that's all. Apart from that, CP cannot tell to you, right? It's kind of that. You are absolutely independent. Correct? समझ में आ रहा है? You didn't get it. Maybe the vector product, if you go to the vector product, it will become clearer. Okay, so do go to the vector product of the 12th or the vector class of the 12th before you go into any of these, right? That will be some 6-7 hours class, so you have to be or more 7-8 hours, yes.